Welcome to Section 7.2. In Section 7.2, we're going to be looking at scientific notation. As a warm-up, I want you to write a power with a given base and exponent. Then I want you to determine which of the following expresses each of those as a power of the number specified. Let's see how you did. For the first one, if we have a base of 6 and an exponent of 3, we wanted to write 6 to the third power. For the second one, if we wanted to write a base of 5 with an exponent of -2, we would write 5 to the -2 power. For number 3, which of the following expresses 64 as a power of 2? Well, if it's a power of 2, 2 has to be our base. So we can cross off C and D. So that only leaves us A and B to choose from. Well, 2 to the 5th is equal to 32, 2 to the 6th is equal to 64, so that's our answer. And finally, the last one, which of the following expresses 1/9 as a power of 3? Again, 3 has to be our base, so we're looking at either B or C. And since 3 to the second power is 9, 3 to the -2nd power is our correct answer. Our vocabulary word for today is scientific notation, and the definition of scientific notation is it's a number written as the product of two factors in the form a times 10 to the n, where n is an integer and a has to be between 1 and 10. You'll notice in the examples here that 5.16 times 10 to the 7th and 8.05 are written in 8.05 times 10 to the -4th are written in scientific notation. The non-examples, 32 times 10 to the 9th, is not written in scientific notation because the first number here is bigger than 10. The second number here, 0.57 times 10 to the -12, is not in scientific notation because it is less than 1. And by our definition, our first number has to be in between 1 and 10. So, numbers such as 12,545 are written in what's called standard form. And a number written in scientific notation has two numbers that are multiplied, such as 4.123 times 10 to the 4th. The first number, remember, has to be greater than 1 but less than 10. This always is a power of 10, and we'll talk about why on the next slide. And the exponent indicates how many times or how many places the decimal point was moved. Positive means we're going to be moving to the right, negative means we're going to move to the left. So this number here, 4.123 times 10 to the 4th, is actually 41,230 in standard form. Looking at the pattern, what do you notice? Hopefully you notice that each time the exponent increases, you add another 0. The reason why scientific notation works is because by adding another 0, we're basically just moving our decimal point. So that's why when we do scientific notation, it has to be times 10 to some power. So let's take a look at this example and see which one is different and why. Hopefully you notice that this one here is different. All of the other ones are in scientific notation. The first one, this number is between 1 and 10, as is this, this, and this. They all have times 10 to some power. This one here is the only one that has a number that's not between 1 and 10, so therefore it is not in scientific notation. So let's take a look at the next one here, and let's see if we can figure out which of these are in scientific notation and which are not. Let's take a look. These three are not in scientific notation because, again, this one is smaller than 1 and these two are bigger than 10. These ones are in scientific notation because they're all between 1 and 10. They're all multiplied by 10 to some power. Again, scientific notation is a number that is written as the product of a factor and a power of 10. The exponent is going to tell us how many times to move the decimal to the left or the right, and the number before the decimal has to be between 1 and 10. Now, we're going to have two types of exponents. One type is positive, the other type is negative. We're going to look at positive ones first. So, in this example, we have 7.325 times 10 to the third. The exponent is a positive 3, which tells us we're going to take our decimal and move it to the right 3 times. So start at the decimal, first, second, third move, so our new number is 7,325. Negative exponents. In this example, 6.1 times 10 to the negative 3, the exponent is a negative 3, which tells us we're going to move the decimal to the left 3 times. So again, we're going to start at the decimal, we're going to move 1, 2, 3 places to the left. We can't leave these as blanks. We have to remember to fill those empty spaces with zeros, and we end up with our new number, which is 0.0061. Let's take a look at this example and try to write the number 678,000 in scientific notation. First thing we have to do is figure out a related number that makes n between 1 and 10. So looking at our choices here, which one is between 1 and 10? Hopefully you said the last one, 678, or 6.78, sorry. So, in order to get 678, we have to move our decimal point. If the decimal point is not specifically written, it's at the end of the number. So we're going to take this decimal and we're going to move it 1, 2, 3, 4, 5 places to the right. So since we're moving it 5 places to the right, we're going to write 6.78 times 10 to the 5th. Let's take a look at these two examples, going from scientific notation to standard form. So first of all, a positive power means we're going to move to the right, and a negative power means we're going to move to the left. So, in this first one, we're going to take our decimal point and we're going to move it 7 places. 1, 2, 3, 4, 5, 6, 7. And you don't really need the decimal point at the end, you can put it if you would like. Now when you're writing a very large number like this, anytime you have multiple zeros and numbers like this, you put commas. You start at the end of the number, and every third group of numbers there, you put a comma. So 52,300,000. In this example, our exponent is negative, so we're going to the left. 1, 2, 3, 4, 5. And this time we have to have our decimal point. So this one is 0.00046. Let's try matching. Let's see how you did. 6.83 times 10 to the 4th matches up with C, 68,300. 6.83 times 10 to the negative 4 matches up with 0.000683. And the last one, 6.83 times 10 to the 8th, matches up with 683 million. Shh. Let's match these up. 9.62 times 10 to the 5th would match up with, correct, this one right here. 2.85 times 10 to the negative 6th matches up with the bottom one, and 6.1 times 10 to the negative 3rd matches this one up top. Let's match these up. Take a few minutes, do these problems, and then come back and we'll see how you did. So, here we go. Go ahead and check your answers. Homework assignment is on page 424, numbers 11 to 33, the odd ones.